The question I had was that even for myself, I constantly mix up intentionally or unintentionally. I constantly use microplastics and nanoplastics. Sometimes I use them together. Sometimes I use one or the other. So from your perspective, what besides the size? I mean, like microplastics are those less than essentially from micron to 5 millimeters. The nanoplastics are those less than 1 microns. What are the key differences between them? I mean, why does it matter? What does the size difference matter biologically? Is one concerning more than the other? Should we care about the size?
Another great question. I too was confused about the nomenclature regarding size. I want to emphasize that size is not just a technical detail. It changes how these particles behave in the body. Now, microplastics are larger particles, and the size that's commonly discussed ranges from about 1 micrometer up to 5 micrometers, and they can still be ingested or even inhaled. Now, many will be likely eliminated from the body when they're ingested or inhaled, but some of these microplastics can be retained, especially if they lodge in the mucous membranes, the airways, or the intestinal tract. Microplastics also can carry as carriers for additives and for chemicals that they pick up from the environment. Nanoplastics, speaking of size, are smaller. They're often described as being below 1 micrometer and sometimes even way smaller than that in the size range of tens to hundreds of nanometers. Now, at that tiny, tiny scale, a few things happen that are biologically important. They can be taken up more readily by the cells in the body through what we call endocytosis, and they can act directly within the cell membranes, and in principle, they may cross biological barriers more easily. For example, the blood-brain barrier, the placental barrier, or in the lungs, the alveolar capillary barrier. Their surface area relative to their mass is vastly higher than nanoplastics, which can increase reactivity and the likelihood of interacting with proteins, membranes, and the bodily intracellular structure. So, from a medical perspective, nanoplastics are especially concerning because they're harder to measure, meaning we may be shockingly underestimating our exposure to them, and because their small size makes them more likely to interact at the level where disease begins. That's oxidative stress, inflammation, mitochondrial disruption, and potential effects even on the DNA integrity and cell signaling. These are some serious biological effects. Now, certainly microplastics matter too, but nanoplastics, I think in my opinion, raises the stakes even higher because they potentially access biologic compartments of the body that larger particles cannot.